In this video, we're asking what you actually need to think about before moving a consumer unit. On this job, the customer is having an extension done and the space under the stairs is being turned into cupboards and storage. That means the existing consumer unit can't stay where it is, so it has to be relocated. Now, it sometimes feels that moving a consumer unit to a customer is a relatively straightforward job, but that is rarely the case, especially when the original location is under the stairs. That space is often part of the escape route, access is usually restricted, and working space is rarely ideal. We're also going to be looking at the meter tail side of things, like why they say it's 3 meters from the service fuse when I bought this 5 meter pack from Doncaster Cables, and if the tails here need mechanical protection, and all of that is coming up. But first we need to understand why these jobs are rarely as simple as they first look. Let's start with where the new consumer unit is going. In this case, it's being moved through the wall into a dedicated planned area that will also house battery equipment. The wall has been battened off, which has allowed a void behind for cable runs, and to contain the cables and keep them neat, we're using these CB02 brackets from Cable Boss. Not the designed application for them, but here they work a treat and allow me to dress the cables as needed. The customer has also asked me to fit the consumer unit lower down so it can fit inside cupboards that they've bought. However, Part M of the building regulations, the one concerned with accessibility, states that the consumer unit should be between 1,350mm and 1,450mm to the switches. Well, I know the customer's not going to be happy with that height, but do I have to install them at that to comply with building control? Well, no, we don't. If this was a new build, we would need to adhere to all the current building regulations. However, as this is an extension and as such is being installed with existing positions at previous heights, we do not need to adhere to those rules. And this is the same for switches and sockets. It is recommended that accessories are installed to allow full accessibility, but you won't be in trouble with building control if you decide to mount the consumer unit at ceiling height. But we also have the existing circuits going to the old consumer unit, and every circuit going to that board has a predetermined length. And if we move that consumer unit even a short distance, then that length might become a limiting factor. Sometimes there may be a bit of slack hidden away, but more often than not, there isn't. So if we have to extend circuits, we do have some options for doing that. One is to use adaptable boxes, but only if they remain accessible for inspection and maintenance. This usually means plant rooms, cupboards, and other spaces that aren't going to be boarded over. The other option is to through crimp the cables to extend them. This is time consuming and a tad fiddly, but also, and my biggest worry, is through crimping on solid core conductors. It's supposed to be okay and a maintenance-free joint, but for some reason I've just never trusted it. But what do you think? Crimping solid core cables, is that something you do? Let me know in the comments. The other option is to use maintenance-free connectors like quick wire, which can be enclosed within walls or ceilings. As long as they are installed in line with the manufacturer's instructions, these connectors are excellent, really secure, and they can make the install so much faster. On this install, I used a 24 amp quick wire to extend the existing house ring main. Ring final. Before I get to the meter tails, let's have a quick look at the consumer unit I'm installing on this install. I've decided to use a 36-way double stack consumer unit from BG. If you're dealing with larger installs, battery systems, or properties where future loads are almost guaranteed, they also do a 48 module version. And there's a good reason why I plumbed for this board on this install. It comes fitted with a 100 amp main switch and a 100 amp 2-pole connector block, so you're not immediately adding extra components just to get the supply connected. It also has the Type 2 SPD fitted and pre-wired, which matters more now than ever. Homes are full of sensitive electronics and those don't respond well to voltage spikes. By fitting a Type 2 SPD at the consumer unit, you're giving the installation a first line of defense against transient overvoltages before they ever reach the final circuits and connected equipment. There's also no requirement for overload protection for this SPD, and that sometimes raises questions. Should it have overload protection? What do you think? And if you've got a question that you want me to answer, then be sure to send it to willittrip@efix.co.uk. From a practical point of view, the board itself is easy to work with. There's an integrated spirit level, which sounds minor but makes a difference when you're fitting a larger enclosure. At the rear, you've got large knockouts arranged in rows along with 40mm knockouts on the sides, top and base, so cable entry is flexible without fighting the enclosure. The terminal screws are backed out and retained, which makes dressing and terminating conductors far less frustrating, especially with larger cables. And once you start wiring it, the space really shows its value. There's enough room to dress cables properly, keep keep bends tidy and avoid having everything crushed just to get the lid back on. It's a solid bit of kit as well. It certainly doesn't feel flimsy, and it can take the odd knock on site without flexing while you're working on it. BG also supply it with an accessory kit with lid retainers and clip-in buzz bars. For the protective devices, I'm using BG's bidirectional RCBOs, which suits installs like this where batteries and energy storage are involved. They'll operate correctly regardless of which direction the current is flowing. They're type A devices, so they won't be blinded by DC pulses. That's important on modern installations where inverters, power supplies and electronic loads can introduce DC elements into the fault current. Using the wrong type of device risks the protection not operating as intended. The 30 mA rating provides additional protection, reducing the risks of serious injury if someone comes into contact with a live part. These RCBOs are also double pole, which makes testing much easier. When the device is off, both the line and neutral are disconnected, which simplifies insulation resistance testing between neutral and earth and avoids parallel pass through other circuits. On an installation with multiple circuits and modern equipment, that can be a real advantage. So with all the circuits in and the existing circuits extended, we now need to tighten up our terminations. And that means torque. Once you start using a torque screwdriver, you may realise, like I did, how easy it is to over-tighten terminations. I over-tightened a couple of screws when I went back over them, and it's really easily done. Over-tightening can damage conductors, deform terminals, and cause issues over time as things heat up and cool down. BG have made it easy to get the right torque settings by having this sticker at the back of the consumer unit, and they've got the same information on the data sheet. So you can go back, torque everything correctly, and know the terminals are secured exactly as the manufacturers intended. We've also installed some control gear inside this board. There's a BG timer clock and contactors controlling the external lighting, working alongside a photocell so the lighting only runs when it actually needs to. And we also used a BG transformer for this rather retro looking door chime. Okay, so what about those meter tails? First is the distance they're allowed to run from the service cutout. That's the fuse at the beginning of the installation, usually before the meter, and it should have some seals on it. The general guidance from the DNO and BS7671 is that unfused meter tails should be no longer than 3 meters in length. But why 3 meters? Well, the cable is sized and selected mainly to protect the supply network and the DNO equipment if there's a fault downstream. The meter tails are essentially the one part of the installation that can end up running through the property without any local protective device dedicated to them. If you think about it, once you leave the cutout and the meter, you've got a length of cable that could be damaged by building work, crushed, pierced by a screw, or degraded over time, especially if it's routed through walls, cupboards, or busy areas. If that cable gets compromised, then the current at that point could be huge because it's right at the incoming supply. That's why the guidance keeps that unfused run short. The shorter it is, the less exposure it has to mechanical damage and the less chance it has to be routed through areas where it can be interfered with later on. So what should we do if we want to go beyond 3 meters? Well, we would need to fit a switch fuse or similar protective device close to the meter. That way the tails are protected properly and you're not relying on the DNO fuse to do a job it wasn't really intended to do inside the property. We're also thinking about installing these tails in the void behind the plasterboard. The stud work is 63 mm, including the plasterboard. That gives us the 50 mm clearance that BS7671 asks for. The cable is also installed in the zone of the consumer unit. But what would you do? Go on the surface or bury it for neatness? I'm still undecided. So there we have it. Moving a consumer unit sounds simple, but once you start dealing with access, escape routes, circuit extensions, meter tails and future loads, it quickly turns into a design exercise rather than just an install. You're weighing up where the board can go, how the circuits get there, how the supply is protected, and whether the system will make sense of it in a few years' time. These are the kind of jobs where proper planning at the start avoids a lot of headaches later on. Be sure to let me know what you'd do with those meter tails and if you've come across any unexpected problems when relocating consumer units. And if you want to go deeper into electrical design, we've done a full suite of videos on this very subject and I've left links in the description.